Hello guys, so this is a question that came up on the 2016 AddMaths paper in the November series, and it's a typical question you might see in the AddMaths syllabus, so it's important to familiarize yourself with it. So although it may look a bit complicated at first, it's actually quite simple and you just need to do a little bit of rearranging. The first thing you want to do is notice that the form that they've given us is raised to a power, so there's no square root sign or brackets or any of that. So we want to first change this part over here because that's the only part that doesn't suit these conditions. So let's just expand the brackets first to get root of q to the power of 5 times r to the power of 5. And we know that the square root represents to the power of half. So this is just q to the power of 5 times r to the power of 5 raised to the power of half. Now we also know that when you raise a power to a power, you multiply the two powers together. So we get q to the power of 5 over 2 times r to the power of 5 over 2 as our result. And we can just substitute this back in to get p to the power of a third times q to the power of negative half times r to the power of 3 over 2 divided by q to the power of 5 over 2 times r to the power of 5 over 2 times p to the power of negative 2 over 3. Now, if we take a look at the way they want their answer to be written out, we have to write everything in the numerator because there's no fraction in that answer. And we also should take note that they want us to have integer values. So if we start to see something that doesn't nicely round out to an integer, then we know we've done something wrong. The way we can bring these values over here, which are in the denominator, to the numerator is by flipping the power signs. So where we have q to the power of 5 over 2, we can rewrite this as 1 over q to the power of negative 5 over 2. So knowing this, we can just change the sign that's on each denominator term in order to bring it to the numerator. So let's do just that. So we get p to the power of a third times q to the power of negative half times r to the power of 3 over 2 times q to the power of negative 5 over 2 times r to the power of negative 5 over 2 times p to the power of 2 over 3. Now all we have to do is collect like terms. So when you multiply two numbers that have the same base, the powers add up. So you get p to the power of a third plus 2 over 3. So that knocks off these two values times q to the power of negative half plus, well, actually we have to subtract because it's a negative power on the other side too. So get rid of those two times r to the power of 3 over 2 minus 5 over 2. And if we notice, this is exactly the form they want us to write it in. And if we simplify this down, we should get integers, which can verify our answer. So we get p to the power of 3 over 3, which is just 1, times q to the power of negative half minus 5 over 2 is negative 6 over 2, which is negative 3. And then r to the power of 3 over 2 minus 5 over 2 is negative 2 over 2, which is just negative 1. So this is our answer, where we get a is equal to 1, b is equal to negative 3, and c is equal to negative 1. Okay, so we're asked to solve the simultaneous equations shown here. So this is another indices question that I took from an AddMaths paper, and it's pretty typical because it combines many different elements other than indices like simultaneous equations. And we just have to simplify it down so we're able to get those simultaneous equations and easily solve it. So I'm going to first start off by labeling the equations. So this will be equation 1. This will be equation 2. So let's start off by breaking down equation 1. So we can see immediately that 8, 4, and 2 are all powers of 2, in fact. So since 8 is 2 to the power of 3, you can write it as 2 to the power of 3 and then multiply it by the current power, which is p plus 1. Divide that by, so 4 is 2 to the power of 2, so it's 2 to the power of 2q now. So that's equal to 2 to the power of 11. And this is much easier to work with because we actually get 2 to the power of 3 plus 3 over 2 to the power of 2q, which is equal to 2 to the power of 11. So this means that because we have the same base that we're dividing by, we can just subtract the indices. So we get 2 to the power of 3p plus 3 minus 2q is equal to 2 to the power of 11. And now we don't actually need the base anymore because we just have to equate the indices. So we get 3p minus 2q is equal to 11 minus 3, which is 8. So we're going to hold that equation for now and move on to solving for equation 2. So equation 2, we see that all the numbers in here have 3 as a common factor. As a matter of fact, they're all powers of 3. So the first number is just 3, so that's okay to leave right now. We're dividing it by 27 to the power of a third. 27 to the power of a third is the same as a cube root of 27, which is just 3, sorry. So we can write this as 3 to the power of 1, and that's equal to 3 to the power of 6q. So similarly, we can just use the laws of indices to subtract. So 2p plus 5 minus 1 is 2p plus 4, which is equal to, 3 to the power of 6q. And now we have the equation 2p minus 6q is equal to negative 4. Now we just need to use these two equations to solve for p and q. So we can see that this equation, if we multiply by 3, will give the same coefficient of q, and we can use that to solve for the simultaneous equations. So if we multiply that by 3, we get 9p minus 6q is equal to 24. So let's write that down alongside the other equation. So the other equation is 2p minus 6q is equal to negative 4. So the point of simultaneous equations is if we want to eliminate a certain term. So we're going to eliminate the 6q. To do that, we have to subtract the equations. And we get 7p is equal to 28, which means p is equal to 28 over 7, which is equal to 4. And now we just have to solve for q. So we're given, we can just use this equation over here to help us. So we're given that 9p minus 6q is equal to 24. So 9 times 4 minus 6q is equal to 24, which gives us 36 minus 6q is equal to 24. If you rearrange a bit, you get 6q is equal to 12. So q is equal to 2. Therefore, to solve these equations, we get p is equal to 4 and q is equal to 2.